Good afternoon, one and all. I know it's very difficult to follow up to a wonderful presentation, but also another point is that to find something as a technical paper in such a general discussion. Anyway, I'll try to keep it as general and as informative as possible. So, the topic that I would be presenting is on the degradation of organic pollutants in drinking water by non-thermal plasma. So, I believe that this method was probably not in the list of water treatment of Mr. Anil. So, let us see how that could actually work out. So, the people who are involved in this project is myself, Ajay Krishnan, representing the Rheinhausen Group. There is also Dr. Jürgen Kolb. He is from the INP Greifswald Institute or the Leibniz Institute of Plasma Electrification in Germany. There is also Dr. Rafiq Azam, who is from RWTH Aachen University. There is Dr. Uwe Kaltenborn, who is representing high-volt test equipments, and Professor Sarathi from IIT Madras. So these are the people who are involved in this project. So what are the motivations for such or taking up such a project? One of the main things that I would say is Germany as well as India have this issue of a lot of pharmaceutical elements in the potable water. So that was one of the starting points. Another starting point is what are the essentials that we require for social development of rural infrastructure? You see, generally, probably the order has changed in the last few years, where probably if you ask someone 10 years back, they would say lighting and food safety, that is refrigeration or something of that sort, cooling, food treatment, that is more important, enabling of clean water, access to communication and information. I know that as of now, that is the first priority, and then protection of the environment. Mr. Anil actually mentioned something regarding integration of, different sources of water. I would say we need to also integrate different, you can say, not just sources of water, but then also the different types of energy providers. If you say water is one such energy or form of energy, there is power. So I'm actually very much happy that this discussion is happening in a smart grid event. We can even call it a smart city event, where water and power have a lot of interdependencies. So if you see for rural development, a lot of focus is there on renewables. I would like to warn you in the beginning that I'm an electrical engineer, so you will find some slides for regarding electricity, microgrids, and so on. So as you see, this quantity is developing. The potential for renewables is developing. 350 gigawatt is what is stated by 2030 or 32. But then when you see rural electrifications, nearly 50% of the rural population, which is about 80 million households, has no access to grid-based electricity. So what are we looking at here? This could be achieved by a microgrid. So what is basically, and you can say an off-grid connected electricity system where you can light up your homes, you can develop it to treat water, you can have storage. So when you interconnect a lot of such microgrids, you're coming to a stage where you're building up the network from below. Maschinenfabrik Rheinhausen, MR, is associated with IIT Madras on a research project on microgrids based on islanded operation. This is something that Germany sees as a future for India, because when we think of a lot of, you can say, villages or even small parts of the cities, it could be a single building which could operate on its own when the power is not there. So it is about detecting this islanding and then operating in the islanded mode and then resynchronization to the grid when the grid is back. So this is something that we are carrying it out. It so happens that this presentation of the electrical part of the microgrid, this is being presented in another hall by one of the PhD students from IIT Madras. So there has been a lot of talk on how storage could be used. So when we say storage, the first point that comes to everybody's mind is batteries, flywheels, what not. But can we use storage to actually enable another important commodity, that is water treatment plant? And again, water, you can split it up for drinking, agriculture. Why do we split it? Because probably the requirements of both are a little bit different. So, what is a treatment system look like in general? Or what is it that we see as a treatment system for the future? It should have modular units such that, it could be easily replicable into a smart grid or a smart city environment. It should be small and compact. It should be, serialized and parallelized to increase the capacity as well as functionality. And mainly it should be maintenance free. This was also some of the requirements which Mr. Anil mentioned. So, what is the process that has been developed? It's a batch processing system, full electrical treatment with corona discharge, and the objective is elimination of critical pharmaceuticals. So, the first step in that process is electrocoagulation, where you produce metal ions and then metal hydroxides are formed, which acts as adsorbents, and it runs over a process of hydrolysis, condensation, and complexation. So you could also see in the figure that how aluminum hydroxides are separated, and then this is the first step of such a water treatment system. And then we have the plasma system and the pulse generator, where you apply high pulses of about between 50 and 80 kilovolt, and then for a very short period, which is about 2 microseconds or so, and you increase or you provide these pulses with variable repetition rates between 10 and 100 hertz. And the major point in this is that the pulse width, voltage levels, and the repetition rates are varied according to the pharmaceutical requirements. So, such a water treatment system could be developed taking into consideration the local requirements of water. And there are different ways in which this plasma system could be actually built up. So one such is the water sprays. A lot of aspects such as rate of oxidants and everything are also taken into consideration. So what are the investigated pharmaceuticals? This was mainly carried out by the IIT professor at one of the hospital discharges, you can say. So this was also found at different locations as to in the potable water. So these are some of the pharmaceutical elements. So how does a plasma filament react against different contaminants? So UV light basically destroys DNA. There is also this component of shock waves, because you're sending these high voltage pulses at a very kind of microseconds. So cells are torn apart. There is also this high electric fields which destroy the cell integrity, and then the chemical reactive species which is such as the hydroxyl radicals, they provide a strong agent for oxidation of stable chemical compounds. So this was the setup that was you can say created in INP Greifswald. So what were the results? So I will also show you some of that. You could find that in terms of pH values, it was not changing. Conductivity increases, and also the concentration of dissolved oxygen doubles. No chemicals or catalysts are necessary, so in this process, and similarly, no pre or post processing other than filtration is required. But the main mechanism of degradation is actually oxidation by high concentration of the hydroxyl radicals. There is also a slight increase in concentration of nitrite and nitrate ions, you can say, but they are well within the legal or the allowable limits. And this is something which is important when you look at how can we use these parameters, in the sense when you look at nitrite and nitrate concentrations, could it be used probably as an element in terms of water that is used for agriculture? Because then that would end up as a fertilizer. So let me sum up by saying that microgrids will definitely play a crucial role for conversion of existing power grids to sustainable grids with high penetration of renewables. In terms of energy storage, concepts of utilizing the surplus energy can be seen, which we see in terms, we see storage as equivalent of usage. And in this process, it has been found that stable pharmaceuticals, even X-ray contrast agents, are effectively decomposed by pulse corona discharges generated in water. Also, as I mentioned, pH value and concentrations of nitrites or nitrates are not affected, and this could serve as potential application in irrigation as well as for treated water. So what are we looking at here? We have been trying to find an Indian industry partner who could take up such an implementation. But as an industry from Germany, it has not been easier. What is also kind of a question mark is how will such a new technology replace the existing methods? One such comparison which we have carried out internally, we also found that this methodology to be much better than the existing methodologies of UV treatment or whatever that you have listed out. So I would like to conclude my speech with that. Thank you.